In this video, we are going to talk about the Pearson product moment correlation coefficient. It is denoted as R. And the description over here will interpret the result for our formula here, for the result of our R. And if we're going to talk about the correlation, always remember that it talks about the relationship, the effect, or the impact. Now, for the data, we have X and Y. Always remember that for the data of X, that is for our independent variable. If we're going to talk about the independent variable, it talks about the values that can, or the variable that can affect the dependence result. Now, if we're going to talk about the dependent variable, it is the variable being affected by the independent variable. For example, we have the plant and we have the water. The water will be our independent variable and the plant will be our dependent variable because the plant's growth will depend on the water. Okay. Now, let's say that we already have the value for X and we have the values for Y. And these values over here will be taken from the survey. Now, always remember that you should not forget these labels here too, so that you can answer your formula. Now, let's say we have this. Now, to get the XY, all you have to do is to multiply 1 and 30. The values for X and Y. You really have to multiply that one. So 1 times 30 is equal to 30. 2 times 25 is equal to 50. 3 times 25 is equal to 75, and so on. Now, for the X squared, you're going to find the value for X. Where? Over here. Okay. Now, since it's squared, all you have to do is to multiply by itself. For example, we have 1. Multiply by itself. 1 times 1 is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. And so on. Now, if we're going to talk about the Y squared, all you have to do is to multiply by itself. Where can we find the Y? On the second column, right over here. So all you have to do is to multiply 30 by itself. 30 times 30 is equal to 900. 25 times 25, 625. It's the same as you say 25 squared is equal to 625. Now, since we are already done with this part, all you have to do is to sum the values per column. So, if we're going to add these numbers, that will result to 21. This one will result to 110, 30, plus 50, plus 75, plus 40, plus 75, plus 30 is equal to 300. The sum of these numbers is equal to 91. And these numbers is equal to 2,500. Okay, since we're done with here, the next step that we're going to do is to use the formula for correlation, the Pearson's R. Now, all we have to do is to substitute these variables here. Always remember that our N is our sample size, or the number of respondents. Now, how to identify the number of respondents? Just by looking at the table. Just look at these rows. How many rows do we have? 1, 2, 3, 4, 5, and 6. Therefore, Rn is equal to 6. Now, where can we find the summation of xy? So, by looking, where is our xy? Here. And the summation is 300. Now, let's go back to the formula. So, we have 300. So, that's how you look. Now, always remember, on this part, you should know the difference between them. By looking at this one, we have the summation of x squared. Now, it's different with the summation of x squared. Now, to look for the summation of x squared, we have here. So, that's why we have 91. Okay. Now, for the summation of x, we have 21. So, we're going to put 21 here and just put squared on the outside of the parenthesis. Okay. Now, take note that we're going to use calculator to easily solve this one. Now, if you're going to input the calculator, always remember that you should not miss a single icon. For example, you're going to miss an icon here like parenthesis, additional parenthesis. If you're gonna miss a single icon, your calculator will result to syntax error. So you should not miss a single icon. Now, in these values here, the result for that is negative 0.92422, or approximately to negative 0.924. We just rounded off this one to the hundredths place. I mean thousandths place. Okay, now remember negative 0.924. Let's go back to the description. So where can we find the negative 0.924? So it's right over here, and it is interpreted as strong negative correlation. Now, since it's strong negative correlation, if we're going to plot this one, it is something looking like this. So strong negative correlation, just like that.